Hey, welcome guys. Today's tutorial will be based on arithmetic arithmetic series. Okay, so when we're talking about an arithmetic series, we refer to the sum of the terms in the arithmetic sequence. And remember that the arithmetic sequence just means linear. So a linear sequence is arithmetic sequence. Okay, so we'll be looking at arithmetic series. So basically, when we talk about arithmetic series or a linear series, or taking to it's more like it's not this one is not a pattern. It's the same as a pattern, but now we're talking more about the sum of the terms in that pattern, or the sum of the terms in the linear pattern. Okay, so the formula for a linear arithmetic series is as follows: Sn equals to n divided by 2 into 2a plus into n minus 1 multiplied by b. Okay, this is still our first difference. And this is the number. This is no longer the position. It's now the number of terms in the in a series. The number of terms is no longer the position is now the number of terms. Okay, then a is still the first term, then n is the number of the number, or like I said, it's the number of the terms. Then this one is the s refers to the sum. So when we're writing as n, we're saying the sum of n terms. Okay, I hope you understand, guys. So I'm just gonna show you. I know this is kind of like difficult to digest. So this is a series. The s just basically show that it's a series. Okay, the series, when you have a sequence is more like having t1, then having t2, having t3, like that. But then when we're talking about a series, we're just going to add them. We're just adding the terms. That's what happens in the series. Nothing much changes. It's just you gonna use addition instead of semicolon or the column. So yeah, okay, that's how a series goes, and that's how I can explain it. Just refer to the sum of the terms in that pattern. When you're talking about arithmetic or a linear series, it means the sum of the terms in the linear series or the arithmetic series. Sorry, in the linear pattern, or when we're talking about arithmetic series, we're talking about the sum of the patterns in an arithmetic sequence or a linear pattern. Okay, cool. I hope you understand. So like I said, A is the first term, N is the number of the terms, and D is the difference. Okay, the only thing that changes just now, it's just now, and it's no longer a position, it's the number of the terms. Okay, so we're gonna start by proving these. So the proving for this one, I'm gonna have obviously to record 2 lectures because the proof takes long and it's important, and it's always in every exam mostly. There are sorry, there are 9 out of 10 chances that it can be in your trial exam or your final exam for paper 1. Okay, so when proving these terms, you need to listen attentively, guys. Like I said, this is just from a linear or an arithmetic sequence, which has the form of Tn is equals to a plus, but this one is not bright. Okay, let me just try to use this one. Okay, like I said, the arithmetic series just refer to the sum of the terms in arithmetic pattern or in a linear pattern. So, but then we know that proof. Let me just start by saying proof required to prove Sn equals to 2 over. Oh, sorry, Sn is equals to n divided by 2 into, is it 2 into 2a plus, I need to make sure, and minus 1 multiplied by b. Okay, but then we know, like I said, this is basically the sum of the terms. I keep on repeating this because it's important. like I said, it's just the sum of the terms in a linear pattern or an arithmetic sequence. But then we know that our arithmetic sequence has the form of Tn equals to a plus into n minus 1 multiplied by d. We saw it from the linear pattern. Linear and arithmetic is just the same thing. Okay, guys. So yeah. Then we know, then according to the theoretical definition, we know this is the sum of the terms. Then we can just say t1 plus t2 plus t3 plus t4 up until the last term, which is going to be tn. Because if I say we have 5 terms, meaning our last term will be t5. Okay. Then this means the sum of 5. This basically means the sum of all these terms. Okay. So therefore we know that we know that okay, Sn equals to, we know we can represent each and every term in this sequence by reversing them. So we're going to more like reverse the terms, or before we reverse them, let's break them down. So we know that the first term is a, and then since linear pattern has a constant difference, we know in order to get t2, what's going on to the right of the screen? Okay, so then we know, since this is a linear, since we know those terms are from a linear pattern, we know in order to get t2, we just have to add the same constant difference, which is similar to the, I don't know if I still have the notes here. Let me go up there here. Yeah, we know our d is our constant difference. So in order to get the next term, we can just add that difference because it's the same. Okay, this is t2. Then in order to get t3, we have to add the difference twice, meaning it's the same as a plus 2d, until tn. We know that our tn is going to be equals to a plus into n minus 1 multiplied by d, which is going to be our last term, right? Then now you're going to swap or write them in a reverse order. You're going to start with the first term. So this is equation. Okay, let me just say this is equation 1. This will be our equation 1. Okay, then now you're going to swap them. Okay, I'm gonna try to use a different color. Now we're going to swap them. When I have Sn equals to, we're going to start with the last term, equals to a plus n minus 1 multiplied by d, therefore plus the term that comes before, the terms that come before the last term, which is going to be plus a plus into n minus 2 multiplied by d, plus the term that comes before the second last term, then going to be equals to, so why did I put the brackets? Okay, plus a plus into n minus 3 multiplied by d, then plus up until it will be plus a. So this is the reverse of the equation 1. Then we're going to name it equation 2. Okay, let me just try to zoom out. Okay, it's not allowing me to zoom out. It's fine. Okay, then now we have our equation 1 and equation 2. So then we're going to add our two equation. And since this is Sn and this is Sn, so when we add our two equation, we're going to have 2 Sn equals to, so obviously the a, you're going to, when you add a and a, is going to be 2a, right? So we're going to have 2a plus n minus 1 multiplied by d plus 2a, because this a will pair with this a now, into, sorry, 2a plus, okay, let me put it in a bracket so that you don't get confused. 2a plus, what's going on? Why is this method doesn't want to write 2a plus into n minus 2 multiplied by d plus a plus, okay, why did I write a? Because this is 2a plus 2a plus into n minus 1 multiplied by d, okay, until the last one, which is still also gonna be 2a plus into n minus 1 multiplied by d. So if you can just try to add all the terms, you will see it's going to be like this. So yeah, then afterwards, then some of the terms, then if we multiply out the brackets and keep on adding them, we'll see that some of the numbers will cancel each other. Then we'll be left with 2s n equals to n into 2a plus n minus 1 multiplied by d, and this will be, then if we divide both sides by 2, we're going to have Sn equals to n divided by 2 into 2a plus n minus 1 multiplied by d. Then now we have proved. So now we have proved our equation. Then we can get our A plus. You can get your A plus in A1. So, okay, I'm gonna try to explain this proof again before I end this tutorial. So we are going to prove the formula that we use in a series, and we know that arithmetic series and quadratic series are different. Sorry, arithmetic series and geometric series are quite two different things. So now we were focusing on arithmetic series. So we need to prove this formula for arithmetic series, which goes as follows: Sn equals to n divided by 2 into 2a plus n minus 1, okay, plus n minus 1 over by d. But then we know that arithmetic series, it refers to, okay, arithmetic series theoretically it's more of the sum of the terms in a linear pattern. Then mathematically is this equation, okay, is this equation here. But then we know our linear pattern is given by this general formula, which is a plus into n minus 1 multiplied by d. Then since arithmetic series is the sum of the terms in the linear pattern, we can just write s of n is equals to t1, t2, t3 from the linear pattern. Okay, but then we know in a linear pattern our first term is equals to a, and we know a linear pattern, in a linear pattern that we have a constant difference between consecutive terms. Therefore, for term 2 we can just say a plus d. Then for the third term, since we're gonna add the constant difference on the second term, we're gonna have a plus d is going to be a plus 2d. But then we always know that if we have our formula as Tn equals to a plus into n minus 1 multiplied by d, that n represents the position of the term in the linear pattern. Okay, so meaning our last term will be the value of that n. If we have t5, therefore meaning we have 5 terms in that pattern. Okay, then here our t, we have tn. We can just sub this general formula from here. Okay, therefore then we can just break them out. Then we call this equation 1. Then we make a second equation. We make this new equation by starting to write this one as our first term, and the one that comes before it here is not this, is the one that comes before it. Then we write all of them until our last term is going to be a. So we just swapping the position. Okay, we're writing them in a reverse order, but it's gonna be two different equations. Then afterwards we add the two equations. This is Sn, this is Sn, these are the same terms, so therefore we can add them. We're going to have 2Sn. Then if we add this, when you look at this, if you add, you're gonna say a plus a is gonna be 2a plus n and going on again, going on like that. So we're gonna have the same values, but some of them gonna have the different signs. So then when you add this thing, if you can compute it down, but you don't have to compute it in exam, you can just have to understand what's going on, then you're going to be left with this part. You're going to be left with 2SN equals to 2N into 2A plus N minus 1 multiplied by D. Then when you divide by 2, you're going to be left with Sn. Then your value of Sn is proved. Then you get your marks. Thank you guys. Thank you for being with me. Also, this was one of the longest video. There was no way I can cut this video short because you have to understand this proof. And yeah, I hope you enjoyed this, and I hope I became a bit better than your teacher. But don't tell them I told you this. Thank you. Enjoy.